So in this exercise, we're given the gradient, which is this function over here, and therefore we know that the partial derivative of x will be the first part of the gradient, and then the partial derivative of y will be the second part of the second part of the gradient exactly. And in the first question, they're asking us calculate the Hazen matrix of the function. Okay, so therefore we have to find the second partial derivative of the partial derivatives. In here, I have shown how I've calculated the second partial derivatives by looking at the first partial derivative and looking and representing the x value and the y value. In here, that's what I get. And that's for the y. Looking at the this is the function that I'm looking at, the y partial derivative, and then this is the second partial derivative of y. And same here, I look at representing x and representing y. For example, I'll do one with you. So here I can see that here I have to focus on only x first. Therefore, it's a constant. Therefore, the y has to stay because it's a constant, it's multiplication. And because I was looking at x, this goes off. This cancels out because x is equal to 1. And y I ignore it. Doesn't matter. Then once I calculate these values, I put them in the Hazen matrix format, which is 6x. Here I see. Okay, this is the first. This is the first section, and then in the second section they asked us to. In the second section they asked us to justify the P1. They give us 1 point, and we have to find if we have to justify it. Okay, so we plug in the first Hazen matrix, we plug in the values 1 and 0, 1 for x and 0 for y, and we get these results. Therefore, after this, we have to find the determinant of this Hazen matrix, considering the coordinates, and we get that a times c, so 6 times 3 minus b squared, which is 0, is equal to 18. Therefore, we have the determinant of Hazen metric is 18, and using the theory, we know that if the Hazen metric is larger than 18, it looks at the local minimum or local maximum, and if the a value is larger than 0, which in this case is 6, it shows the local minimum.